Okay, so hello everyone. In this video, we will cover data link layer. So, in this video, we will discuss about definition and working of data link layer, functionalities of data link layer. In functionalities, we will see hop-to-hop delivery, flow control, error control, access control, physical addressing, and framing. So, the data link layer in the OSI model is the second layer from the bottom. Okay, you can also call it the layer that sits in between network layer and physical layer. It takes data from network layer and provide data to the physical layer, and then the physical layer sends the data further through the network so that it can be received by the receiver. Okay, it enables data transmission through the network. Okay, the main important question here is what is the responsibility of the data link layer, or what are the functionalities of data link layer? If in my stream all these 7 layers are working properly, then what is the responsibility of data link layer? How actually does it provide help in the network? Okay, so how does the message or data move from one place to another, and what is the role of data link layer there? So that is what we are going to discuss about one by one. Okay, now the first responsibility or the first role is hop to hop delivery. This is a very important point. Hop to hop or node to node delivery. Okay, what is the meaning of hop to hop or node to node delivery? We will understand from this example. Okay, let's say there is a network A and network B. Now in network A, what do I have here? Some hosts are there, some nodes are there, and those nodes are connected through a topology. Okay, various topologies are there: mesh topology, star topology, we have bus topology, and ring topology. Okay, different topologies are there. Let's say through a particular topology, nodes are connected and devices are connected. Okay, and there is another network B where we have bus topology. Okay, we used bus topology in B network B, and they are connected with bus topology. Now here, what is the responsibility of data link layer? The first very important point is whenever the data link layer will work, it will work within the network. Okay, inside a LAN within the network. When two or more devices want to talk or communicate, the data link layer is sufficient for that work. Okay, this is a very important point. Within a network, within one network only, can I provide communication with the use of data link layer? Yes, I can provide communication with the data link layer by using MAC address or physical address. We have studied it before. Okay, but what happens when we are talking about internet working? Because what is internet? It is collection of different networks. Okay, one network might be in India, another maybe in Australia, one in New Zealand. Okay, so here we are talking about two different networks. If I am sending data from network A to network B, it will not be transferred directly. Okay, it will not go directly from like here to here. Okay, there is some media, there is some channel. Through that channel, data will flow step by step. Okay, now if we talk about hop to hop delivery, hop is nothing but we can say a device. Okay, a single device is connected in network is a hop, or we can say node. Okay, here in the middle I have represented the routers R1 and R2. Multiple networks are connected through routers. These routers we can also call them hops or intermediate nodes. Okay, let's say here A4 wants to send data to B1. Okay, A4 wants to send some message. Okay, A4 here is the sender and B1 is receiver. Now this data will not be sent directly. Okay, it will have to follow the proper path, follow proper intermediate nodes. Okay, so here what is the responsibility of data link layer? The responsibility of data link layer is to hop delivery, one device to next immediate device. Okay, hop to hop delivery. When the message starts from A4, to which node will it go first? I know that after the message travels through multiple hops, it will finally reach the B1. But the responsibility of data link layer is not to worry about the final destination. That is the responsibility of network layer. Okay, which determines that how to move data from source to destination. That responsibility of network layer. The responsibility of data link layer is much more focused. When a message starts from A4, that message goes first to which router or node? This is the responsibility of data link layer. From A4 to the first router R1, the responsibility of data link layer. After that, it reaches this hop. Okay, now this router may be further connected to many routers or many networks, but I have to send it to the next appropriate router. Okay, let's say R2. So to send R1 to R2 is again the responsibility of data link layer. Then sending further from R2 to the next hop is again the responsibility of data link layer. So what work is the data link layer doing here in the background? Hop to hop delivery. It is not saying that I will take the message from A4 directly to B1, or I will move from this network directly to that network. Okay, its primary function is node to node delivery, hop to hop delivery. Okay, which node will my message reach first as soon as it leaves the current network? Then which node will it reach from that node? From that node to which next node? Okay, in this way finally it will reach the destination network. Okay, so that is called hop to hop delivery or node to node delivery. This is the most important concept of hop to hop delivery. Now, the second responsibility is flow control. Flow control. What is flow control? It is clear from the name itself that when the source is sending a message, the source is sending a message to a destination or to a next hop. So the flow has to be controlled properly. Okay, what is the meaning of flow control? At what speed should the message be sent? If A4 is generating messages at a very fast speed and sending them to R1, it is possible that R1 gets overwhelmed with the messages. Okay, when a router or node gets filled with the messages, let's say many messages start coming to your mobile immediately, then you will have to delete some messages. That means you may be reading some messages, but when the buffer gets filled, old messages will get deleted automatically. Okay, that means when we increase the flow very much, R1 will be filled completely with the messages, and in that case it becomes very necessary to control the flow. Okay, this is flow control. Now, so here, in order to control the flow, various methods are used in the data link layer. Okay, one is stop and wait protocol, second is go back and third is selective repeat. We will discuss these one by one in our upcoming videos: stop and wait, go back and selective repeat. These are the three main algorithms which work for flow control. Now, if you look carefully at an important point here, flow control we will learn also in the transport layer. But what is the functionality of flow control there in transport layer? That is source to destination flow control. Okay, the transport layer will take care about the destination B1. What is the capacity of B1? Okay, that will take care by transport layer. From the source, when I send a message, what is the size of the receive window size at B1? Okay, how many messages can B1 accept? What is the size of those messages? The transport layer will take care of all of that. Okay, but how will this message reach B1? It will reach hop by hop. So what is the data link layer doing here? When a message from A4 reaches R1, then what is the capacity of R1? How many messages of the what size can R1 accept? Okay, here flow control of data link layer helps from node to node and not directly from source to destination. So this is the most important point which many students miss. Okay, that flow control happens at two levels: the data link layer control flows at every individual hop, and the transport layer controls flow from the direct source to destination. Okay, so we will reach the destination later, but first we have to successfully traverse every intermediate node. Okay, so whose responsibility is to control the flow at the intermediate nodes? Is the data link layer's responsibility. And how does it do this? Through these three methods, which are very important methods. We will discuss these methods one by one in our upcoming videos, and through these methods it controls the flow. Okay, this is what flow control. Now, the third responsibility of data link layer is error control. Okay, what is meant by error control? Error control is very important, but why? Let's say A4 sent a message to B1. When A4 sent the message, that message traveled through multiple hops, okay, and finally reaches B1. Then now B1 finds that there is an error inside the message. Error means it is possible that a bit might have changed. It was 0 but it became 1. Like this could be a single bit or multiple bits could have changed. Okay, and which is called a burst error. Okay, so here we have to detect the error first. How will you find the error? First you need to have a method that can detect the error and then correct that error if possible. Okay, now when does error detection happen? When A4 sends the message and it reaches B1. After that, B1 realized that there is an error. So what is the important point here? Yes, the data link layer does error control, but not from source to destination directly, but from hop to hop, node to node. Okay, error control will also be implemented in the transport layer. There are different methods used in error control. Let me tell you the methods first. One is CRC, cyclic redundancy check, and another is checksum. One other is we also use parity bits here. Hemming code is also used for error correction. Okay, but the major methods are CRC and checksum. Out of these, CRC is primarily used in the data link layer and checksum is primarily used in transport layer. Okay, so we will discuss these methods in detail in our upcoming videos. Now, one important point I want to tell you again is that the checksum in the transport layer works from source to destination. This means when the message reaches B1, then only we will know that there is an error in the entire journey. But why don't we find out beforehand? If when this message reaches R1 or R2, we already know that there is an error, wouldn't that be much better? Like how much higher will the performance be? Okay, if an error occurs, obviously the message will have to be sent again. It will have to be retransmitted. So if the message first reach reach B1, meaning it traveled the maximum distance, and then we found out that there is an error in it. Okay, so B1 will send an acknowledgement that there is an error, and we will have to send it again, but this will be very time consuming. Okay, what will be the best? If R1 or R2 detects that there is an error and tells A4 to send the message again, this will take much less time and resources. Okay, this means if we do error detection in the data link layer at each hop, then this would be the much more efficient. This is a very important point, okay, about why we need error control at both the data link layer and transport layer. Okay, here are main points in slides about why error control at two layers are mandatory: early detection, quick recovery, and efficient at data link layer, and final check at the transport layer checks entire source to destination path and catches error missed by intermediate checks, as I explained in this example. Okay, now the next functionality is access control. In access control, we use several important methods. Okay, the most important method is CSMA CD, carrier sense multiple access with collision detection. Okay, we commonly call this Ethernet. Okay, or we use different method like ALOHA. In ALOHA, we will use pure ALOHA, slotted ALOHA. We also use token ring or token bus methods. All of these fall under access control. Okay, what is the concept of access control here? We have discussed that the data link layer majorly works within a network. In a network, if A1 want to communicate with A2 or A1 want to communicate with A3, this is possible through the data link layer alone with the help of MAC address. The network layer is not required for this intra-network communication. So in this network, when there is one shared access medium, access means the communication channel. Okay, we are talking about the channel. This could be a thick wire, meaning a cable whose bandwidth is very high. Okay, through this shared medium, multiple devices are connected. When multiple devices are connected through this shared medium, what problems come up? The problem is who will send the message and when. Let's say B1 start sending a message, and at the same time B4 also start sending a message. So what will happen to the message of both? They will collide. Okay, there will be a collision. When the message collide, they will not be useful to anyone. The messages lose their value and become corrupted. So that means collision is a major problem here. That means we need an access control here. Yes, access control means when B1 wants to access the channel, B1 should get exclusive access to this channel. Okay, first, and then it start transferring the messages. When it's sending messages, doing unicasting, multicasting, or broadcasting, at that time B3, B2, B4 should not send the messages simultaneously. So how do we achieve that? By using these different access control method. So whose job is this? It's data link layer's job. Now the next responsibility, or we can say functionality, is MAC addressing that we implement in the data link layer is the physical address, also called as MAC address. Okay, the physical layer address is a 48-bit address. Okay, this address is fixed. This address is permanent. This means if within a network A1 wants to talk to A3, they can communicate through MAC address. Okay, but if two devices in different network want to talk, meaning devices within different network, then MAC address cannot be used for end-to-end communication. Okay, this can be used only in one network. Okay, why can't it be used? When we learn about MAC address in detail, we will compare them with logical addresses. Logical addresses are used in network layer. Those are IP addresses. Okay, the reason is that MAC address is a fixed address. If you change networks but keep the same MAC address, others will think you are still in the same network because the network portion is embedded in the MAC address. Okay, theoretically you could have two network interface card with the same MAC address, but that would be illegal. Okay, no legitimate vendor will issue two identical MAC addresses. Or you can have two network cards from different vendors, but having identical MAC address would create serious network conflicts. Okay, so that is the concept of physical layer and MAC address in the data link layer. Now other than this, we use frames in the data link layer. The terminology we use here is frame. Okay, and this process is called framing. When data comes from the network layer, in network layer the terminology we use is packet. When packet come to the data link layer, we encapsulate them into frames. Okay, when data comes down, we make them into frames and then send them to physical layer. Okay, what advantage do we have with framing? Reliability. Okay, data will be sent properly. The data link layer adds its own header and also adds a trailer. Header and trailer are added by the data link layer. Okay, and this helps in sending the message further correctly. Okay, so that is called framing. It means data will be put in the frame format. Along with that, a header will be added in the beginning and trailer will be added at the end. Okay, in this way the message will be sent properly and reliably. Okay, think of it like a coaches of train. You must have seen goods train. Okay, the coaches there are like frames. Okay, the engine is added in front of those coaches that act like a header, and at the end there is a guard's cabin or compartment with the signals. Okay, that is like a trailer. Okay, what advantages do we have with this? these frames should reach the next hop properly, okay, reach the destination properly. That is the responsibility of that framing fulfills. Okay, so all these responsibilities are fulfilled by the data link layer: flow control, error control, access control, MAC addressing, framing. But remember one point here: not from source to destination directly, but from hop to hop. If I take an example of train again, if the train is going from Delhi to Mumbai, it is not the responsibility of data link layer that the train start from Delhi and reaches Mumbai directly. After starting from Delhi, where does it reach first? It reaches Agra. So how will it reach Agra from Delhi? That is the responsibility of data link layer. Okay, from Agra, how will it reach the next station? Maybe Gwalior. That is the responsibility of data link layer. How will it reach from Gwalior to next station towards Mumbai? That is again the responsibility of data link layer. This means station to station, hop to hop, node to node. That is very important point which student miss many times. So always remember this point: the data link layer handles all these responsibilities, but it is always from hop to hop, never end to end or source to destination. Okay, this is all about the data link layer and functionalities. We will discuss all these functionality in detail one by one in our upcoming sessions. Okay, so that's it for this video. We will meet in next video. Until then, bye bye.